Hey everyone, so have you ever really stopped to think about your browser's back button? How it just knows where you've been? It feels like magic, right? Well, the secret isn't magic at all. It's actually a super fundamental data structure called a linked list. And yeah, it might sound a little techy, but trust me, you use it all the time. So let's pull back the curtain on this little piece of digital wizardry.
So picture this. You're deep down some internet rabbit hole, right? You're clicking from one page to the next, and then you hit back. Boom. Instantly, you're on the last page. You hit forward, and you're right back where you started. How in the world does your browser keep track of all that so smoothly and so fast?
All right, let's break down this little magic trick. We're going to see what it would take to build a browser history feature from scratch, and you'll see pretty quickly what the challenges are.
Okay, so our journey starts at a home page, let's say gfg.org. This is our starting line. Simple enough, right?
From there, we decide to visit google.com. So now our history has two spots in it, the home page and now the search page. We're kind of leaving a trail of breadcrumbs.
And from that search, maybe we find a cool video, so we click over to youtube.com. Okay, so now our history is 3 pages deep.
Okay, now for the interesting part. We hit the back button once. Where does that take us? Right back to our search results on Google. But what about that YouTube page? It's not gone. It's now part of our forward history, just waiting there in case we want to go back to it.
But here's the real twist. Instead of clicking forward to go back to that video, we type in a totally new address. Let's say linkedin.com. And poof, just like that, our forward history, that YouTube page, is gone, vanished. Why? Because by going to a new site, we've started a brand new path, a new branch in our browsing journey.
So the big question is, how do you build this? A system that can handle all of that, going back, going forward, and instantly wiping out the forward history when you visit a new page. You need something fast, something efficient, something that doesn't just lag out after you've visited 100 pages.
Well, the answer to this whole puzzle is a really elegant data structure called the doubly linked list. And it is the perfect tool for the job. Simple, but incredibly powerful for exactly this kind of sequential data.
Okay, so you could try to build this with other things, like a couple of stacks, and that kind of works. But look at this table. The real game changer here is that visit operation. With a doubly linked list, it's O of 1, which just means it's constant time. It's basically instantaneous. It doesn't matter if you have 10 pages in your history or 10,000. Adding a new one is always lightning fast. And since visiting new pages is something we do all the time, that is a massive win.
So what is a doubly linked list exactly? Well, just imagine a chain. Each link in that chain, we call it a node, holds a piece of info, like a URL. But here's the key. Each link isn't just connected to the one after it. It's also connected to the one before it. That two-way connection is the secret sauce. It's what gives it all its power and flexibility.
I love this analogy. Think of your browser history like a train. Seriously, each web page you visit is a train car. Those next and previous pointers, those are the couplers hooking the cars together. And you're the conductor. You're in the current page car. When you visit a new page, you're just adding a new car to the end of the train and stepping into it. And hitting the back button, that's just you walking into the previous car. Super simple, right?
Okay, so linked lists are so fundamental, they're at the heart of tons of classic coding interview questions and puzzles. So let's have a little fun and look at a couple of these to really see how versatile this thing is.
All right, first puzzle. Imagine you're walking down your linked list, but you never ever reach the end. You just keep going and going. You're trapped in an infinite loop. Why? Because somewhere in the chain, a node's next pointer doesn't go to a new node, it points back to one you've already seen. So the question is, how do you figure out you're in a loop without, getting stuck in it forever?
The solution to this is just so clever. It's called Floyd's cycle finding algorithm, but everyone calls it the tortoise and the hare algorithm. And it's exactly what it sounds like. You have 2 pointers. One is the tortoise, it moves forward 1 node at a time. The other is the hare, it moves 2 nodes at a time, so it's way faster. Now, if there's no loop, the hare just runs off the end of the list. But if there is a loop, what happens? The hare is just running around in circles, and eventually it's guaranteed to lap the slow-moving tortoise. The moment they land on the same node, you know you've got a cycle. It's just a beautiful, elegant solution.
Okay, next puzzle for you. Let's say you have a list and you want to swap every pair of neighbors. So node 1 and 2, swap places, 3 and 4, swap places, and so on. But here's the catch. You can't just swap the data inside the nodes. No.
You have to physically rewire the pointers, the connections themselves. This is a real test of how well you can juggle those pointers.
So how do you do it? It's a pretty methodical process. You look at the first pair of nodes, let's say node 1 and 2. You carefully rewire their pointers so that 2 now points to 1. Then, you have to connect that newly swapped pair back to the rest of the list. Once that's done, you jump ahead 2 spots to the next pair and do the whole thing all over again. It's like a delicate little dance, just carefully rearranging all those connections.
So there you have it. From something you use every single day, like your browser history, to these classic brain-teasing puzzles, the linked list is just one of those fundamental building blocks of our digital world. And its real power? It's in its elegant simplicity.
So what's the big takeaway here? It's this. Whenever you have sequential data that's changing all the time, adding things, removing things, linked lists are an amazing solution. Because you're just changing a couple of pointers, inserting or deleting an item is incredibly fast. Now, there's a trade-off, of course. They're not great if you need to instantly jump to, say, the 500th item. An array is much better for that. But for efficient insertions and deletions, yeah, they're really, really hard to beat.
So next time you hit undo in a document or you're skipping through songs on your music playlist, take a second and think about the linked list that's probably working its magic behind the scenes. Once you start looking for it, I promise you'll start seeing this powerful little data structure absolutely everywhere. What other apps on your phone do you think are using them? I'd love to hear your ideas.